We're about to dive into a piece of tech that, and I'm not exaggerating, powers literally everything in your life, but you probably never see it, never even think about it. And right now, this 100-year-old invention is facing a 21st century crisis.
So, let me just ask you this. What's the most important invention that you just don't think about? Ever? No, it's not the microchip. It's not the internet. It's something way more fundamental, hiding in plain sight.
Yep, the electric transformer. That dull gray box you see on a utility pole or that humming substation down the street. It is the absolute non-negotiable bedrock of our entire electrical world.
For more than a century, it's been this silent workhorse, just quietly doing its job, stepping voltage up and down so power can zip across the country and then safely enter your home. But that silent workhorse, well, it's finally getting a radical, truly revolutionary upgrade.
Okay, so let's get into it. To really understand this revolution, you first have to appreciate the pure genius of the original design. I mean, how does this simple-looking box actually work? It all comes down to this beautiful, elegant principle called mutual induction. What that means, basically, is that you can transfer power through a magnetic field without the wires ever actually touching. It feels like magic, but nope, it's just pure physics.
And here's how it all happens in just 3 simple steps. First, you've got alternating current flowing into one coil of wire called the primary winding. This creates a magnetic field inside the iron core that's constantly changing, constantly pulsing. And that pulsing magnetic field, it induces a brand new current in a second coil. That's it. By just changing the number of wire loops in each coil, you can precisely step the voltage up for long-distance travel or step it down to safely power your laptop. Simple, brilliant, and unbelievably reliable.
But, and this is a big but, here's the problem. The grid this brilliant device was built for, this simple one-way street of power from a huge plant straight to your house, that grid is gone. It doesn't exist anymore, and the classic transformer is now under some incredible, unprecedented pressure.
So what's changed? Well, for starters, renewables. Solar panels on your neighbor's roof means power now flows 2 ways, but our old transformers were only built for one-way traffic. And then you've got electric vehicles. Just imagine entire fleets charging at once. That creates these huge, sudden spikes in demand that the old system just wasn't designed for. On top of that, you have these massive, power-hungry data centers that need perfectly stable electricity, 24/7. And the kicker? A lot of our grid infrastructure is just getting old. That old workhorse is really struggling to keep up, and that threatens the stability that keeps the lights on.
So the takeaway here is pretty clear. We need something better. And the solution is evolving down 2 really fascinating paths. One path gives the old workhorse a new digital brain, and the other one replaces it completely. All right, let's start with path 1, which is all about evolution. Instead of ripping out the transformer we know and love, we're just making it intelligent. Think of it like giving that 100-year-old piece of hardware a 21st century software upgrade.
So what does it even mean for a transformer to be smart? Well, we're embedding it with sensors to monitor its health in real time, kind of like a Fitbit for the grid. We're adding communication modules so it can actually talk to the other parts of the grid, and, get this, we're using AI and digital twins, which are basically perfect virtual copies of the real thing, to simulate stress and predict failures before they ever have a chance to happen.
And the results? They're pretty incredible. This whole data-driven approach, this predictive maintenance, can slash unexpected failures by up to 40%. I mean, think about that. That means fewer blackouts and a much more reliable grid for every single one of us.
But what if an upgrade just isn't enough? That brings us to path 2. And this isn't an evolution, it's a complete revolution. It's called the solid-state transformer, or SST for short.
Okay, so take a look at this, because the difference here is night and day. A classic transformer is a passive device. It just sits there using electromagnetism. An SST, on the other hand, is an active system that uses advanced power electronics. That means it's way smaller and lighter. But here's the real game changer. It's built for the modern grid. It can handle power flowing both ways, no problem. It can switch between AC and DC power on the fly. Its job isn't just to change voltage anymore, it's to become an active, intelligent manager of power flow.
And you should know, this isn't just some technical curiosity for engineers to geek out about. The shift towards these new transformers is a massive economic and industrial transformation that's happening right now.
Just to give you an idea of the money involved, in 2024, the global market for these solid-state transformers was already valued at over $172 million. And that's for a technology that's really just getting started.
Right, and that's just the beginning.
The market is projected to skyrocket, nearly tripling to almost $500 million by 2032. That's a growth rate of over 14% every single year. You only see that kind of explosive growth when a true technological shift is taking place.
And what's fueling all this growth? Well, it's all those challenges we were just talking about. Modernizing power grids is the biggest driver, but it's followed closely by EV charging stations, which means more reliable, faster charging for your car, renewable energy projects, and even electric trains. The SST is basically the perfect tool for the grid's biggest modern headaches.
Now, the elephant in the room with any new tech is always cost, right? But companies like Watt EV are tackling this problem head-on. They're designing these modular systems that are specifically meant to make it cheaper and faster to build things like huge charging depots for electric trucks.
And this isn't some far-off future promise. This tech is being tested and rolled out right now. You got Eaton working with National Grid in the US, ABB is using SSTs to power its smart factory over in Shanghai, and the Port of Singapore is piloting them for super high-power EV charging. The revolution is already happening.
So, when you put all of this together, a whole new picture of our energy future starts to emerge. And it's a future that isn't just about building more and more power plants.
The real goal, the real shift here, is to make our grid more intelligent. It's about building a system that's flexible enough to handle energy from any source and efficient enough to direct it exactly where it needs to go, precisely when it needs to get there.
Which really leaves us with one big question to think about. Are we moving into an era where the biggest challenge isn't about making more energy, but about learning how to manage it with a whole new level of digital intelligence? It sure seems like the humble transformer, in its new reimagined forms, is right at the heart of that answer. Thanks for joining me.